So this question asks to evaluate the following definite integral. So if you look at the integral, there's an x squared plus 9. This tells you to use trig substitution. And we see a square root of x squared plus a squared is x equals a tangent theta. We're going to use this formula. Okay, so this one, x squared plus 9, 3/2 is same as square root of x squared plus 9 to the third power inside of the square root. And this is the similar formula as that. So we're going to put x equals 3 tangent theta, and then we're going to find the derivative of that, which is dx equals 3 secant squared theta equals d theta. And then we're going to move tangent theta, we're going to move 3 in front of tangent theta. So x over 3 equals tangent theta, and then theta would be tangent minus 1 x over 3, right? Okay, we have that. And then let's find the new integrand, new integral for this theta equation, because right now integral is in 0 to 3, but like when we changed in the integral interval into theta, we have to like plug it in each value to find the upper and lower interval. So let's do that. Theta equals tangent minus 1, 3 over 3 equals tangent minus 1 to 1. This is same as pi over 4, and tangent, and theta equals tangent minus 1, 0 over 3 equals just 0. So it's from 0 to pi over 4. Cool, love it. Now let's plug it into the integral. So it's 0 to pi over 4, and then dx is 3 secant theta d theta, and then 9 plus x squared is just same as 9 plus 9 tangent squared theta, 3 over 2. Okay, we have that. And then let's distribute the 3/2 in 9 plus 9 tangent squared theta. So if you rewrite it, 3 secant theta d theta, and then 9 3/2, and then 1 plus 1 tangent squared theta. Okay. And then it's gonna be 3/2 for both this one as well. Okay. And what you remember is 1 plus tangent theta, 1 plus tangent squared theta is same as secant square, right? So you can rewrite this equation as 0 to pi over 4, 3 secant theta, and 3/2 theta, and then 9 to the 3/2 power is 327. Okay, so if you do some more calculations, it becomes 0 to pi over 4, 1 over 9 secant theta d theta. Okay, we can take it out 1 over 9, 0 to pi over 4. So secant theta d theta over secant theta will be just same as cosine theta d theta, right? So 1 over 9 sine theta, 0 to pi over 4, integrating, and this becomes 1 over 9 sine pi over 4 minus sine 0. And this just becomes eventually 1 over 9 square root of 2 over 2, so square root of 2 over 18. So the answer for this question is E. Okay, so this question asks which integral arises after making an appropriate substitution to evaluate that integrand. So we see in the integrand 9 minus x squared is inside of the square root. So this is similar format as a squared minus x squared, which makes x equals a sine theta. So if you just look at that, you can write at x is like a squared is 9, so we can write x as 3 sine theta, and we can find the derivative of x, which is dx equals 3 cosine theta d theta. now we have all, so let's plug it into the integral. So we have square root of 9 minus x squared dx. So we can rewrite this into square root of 9 minus 9 sine squared theta. Now times dx is 3 cosine theta d theta. If you remember it, you can group 9 minus 9 sine squared theta into 9, 1 minus sine squared theta, and 3 cosine theta d theta, right? And then square root of 9 will just come out as 3, and 1 minus sine squared theta is same as cosine squared theta by the trig identity. Cosine squared theta plus cosine squared theta equals 1. So we can write this as 3 cosine squared theta inside the square root times 3 cosine theta d theta. Square root and square root can be cancelled out, so 3 cosine theta times 3 cosine theta d theta inside of the integral. This just becomes 9 cosine squared of theta d theta, and this just equals to answer C. So the answer is C. So this question asks the partial fraction decomposition of 1 over x plus x cubed is, so you have to find the partial fraction decomposition of 1 over x plus x cubed. Since they have both x on the denominator, we can rewrite this equals as 1 over x, 1 plus x squared. And 1 over x plus x cubed can be written as x over a plus 1 plus x squared bx. The reason that we are trying to write it like this because we want to find the partial fraction decomposition, and when you see like two factors, then you can divide it. You can write some numerical number that you don't know over x plus 1 plus x squared like this. And since it's like squared value, you have to have an x in the denominator. That's the important part in this question. So when we have this equation, we can do multiply x plus x cubed in both sides to eliminate the denominators. So this just becomes 1 equals a 1 plus x squared plus b x squared. Lovely. Okay, now let's plug in the values in x to find a and b value. So we're going to do x equals 0 first. X equals 0, 1 equals a plus b 0. This is just 1 equals a. We found the a value. Lovely. Okay, now let's find the x equals 1 value. So when x equals 1, this just becomes 1 in this side. And then a 1 plus 1 plus b. So 1 equals 2a plus b. Since a is equal to 1, you can just write as 1 equals 2 plus b. So b is negative 1. So once you find all those values for a and b, you can rewrite this equation in here as 1 over x minus x over 1 plus x squared. This is just same as the option C. So the answer for this question is C. So this question has to evaluate the integral. So let's write the integral first. It's from 0 to 1. 3 plus 2x minus x squared dx. And you see minus x squared and 2x. So what we can do is group it together. So 0 to 1, square root of 3 minus x squared minus 2x dx. And then we see x squared and minus 2x. And what we can do is completing the square. So it's 0 to 1, square root of 3 minus x minus 1 squared. But if you write this, this is just negative x squared minus 2x plus 1. So this is just same as negative x squared plus 2x minus 1. So if you look at the original equation, we don't have a negative 1 in the original integrand. So what we do is plus 1. So in order to make it, in order to just delete the negative 1. So this just becomes 0 to 1, 4 minus x minus 1 squared. Okay, we have that. And this is kind of similar format as a squared minus x squared, and this just becomes x equals a sine theta, right? So it's like similar, but it's a little different because it's x minus 1. So we're going to draw the triangle. So this is theta, this is 2, x minus 1, and square root of x4 minus x minus 1 squared, and dx. So what we can do is sine theta is equal to x minus 1 over 2, and this just becomes 2 sine theta equals x minus 1, and x becomes 2 sine theta plus 1, right? Okay, and then in order to find the derivative, you just derive it from 2 sine theta plus 1, which is just same as 2 cosine theta d theta. And now you have to find the upper and lower bounds. So what we can do is plug in, before we plug in, we need to just leave the data by itself. So what we are going to do is divide 2 on both sides. So this becomes sine theta equals x minus 1 over 2, and do inverse sine x minus 1 over 2. So plug it in the 1 first, then it just becomes sine minus 1, 0 over 2, so this is 0, so 0 for upper bound, and sine theta, theta equals sine minus 1, plug it in 0, this just becomes negative 1 over 2, which is same as negative pi over 6. So this is our lower bound, and this is our upper bound. Okay, we have that. So what we can do is put in the values in the interval. So this thing, 0 to 1, square root of 4 minus x minus 1 squared dx can be written as negative pi over 6 to 0, square root 4 minus x minus 1 is same as 2 sine theta, so it's just 4 sine squared theta, and dx is 2 cosine theta d theta. And let's group the 4 inside of the square root, so this just becomes 4, 1 minus sine squared theta, 2 cosine theta d theta. Negative pi over 6 to 0, 2 can cancel, like square root of 4 can be come out as like 2, so this is just 2, and then we also have 2 in front of the 2 cosine, so this is just 4. So 4, and then 1 minus sine squared theta is same as cosine squared theta. So this is 4 square root of cosine squared theta, cosine theta d theta. Negative pi over 6 to 0, 4, this is just cosine theta times cosine theta d theta. So this is, I'm going to move this into here, sorry. So this is just negative pi over 6 to 0 for cosine squared theta d theta. Okay, we have that, and then it's cosine squared theta. So what you can do for this question is, if you remember the double angle formula, something like that, this is just same as 4 negative pi over 6 to 0, and cosine squared theta can be written as, 1 plus cosine 2 theta over 2 d theta. Okay, and then what you can do is cancel out 4 and 2 by dividing each other. So this just becomes 2, negative pi over 6 to 0, 1 plus cosine 2 theta d theta. If you integrate this, this just becomes 2 theta plus sine 2 theta over 2, 0 to negative pi over 6 to 0. Let's plug in 0. This is just becomes 0 plus 0. Cool, minus 2 and negative pi over 6 plus sine 2 negative pi over 6 over 2. And this just becomes, this is just 0. So this is going to be 0 minus 2 minus pi over 6, and then minus 2, and then times 2 sine minus pi over 3. this just becomes pi over 3 for this one, and then we have a negative sine pi over 3, negative pi over 3, because 2 and 2 cancels out, and sine minus pi over 3 is just same as, negative square root of 3 over 2, and we have a negative sign in front of it, so this just becomes pi over 3 plus square root of 3 over 2. So the answer for this question is E. Okay, this question asks to evaluate the integral. So if you remember it, secant squared theta is same as 1 plus tangent squared theta. So 0 to pi over 3, secant squared theta minus 1 d theta can be written as 0 to pi over 3, 1 plus tangent squared theta minus 1 d theta. So this is just 0 to pi over 3, tangent squared theta, square root d theta, and this is just 0 to pi over 3, tangent theta d theta. So if you remember the tangent theta, it's you can write it as sine theta over cosine theta and solve it from there, and just do the use substitution or something like that. But I feel like it's easier to do it just as like remembering tangent theta is the integrand of, if you integrate the tangent theta, this is just ln secant theta. And if you know this, you can just plug it in the direct value. So ln secant pi over 3 minus ln secant 0. And this just secant pi over 3 just becomes, this is 60 cosine 60 degree over 1, so this just becomes 1 over 1 over 2, so this is 2. This is just ln 2 minus secant 0, so cosine 0 is 1, so ln 1, which is ln 1 is just 0, so this just becomes ln 2. So the answer for this question is C. Okay, so this question asks to evaluate the integral. So we see 3x minus 1 and e. So what we're going to do is a use substitution, but there's a formula, if you remember it, light, L as log, and I as inverse trig, A as algebraic, and T as trig, E as exponential. So in this order you choose U as, like, if it's like log, you choose U as, like, if you see, like, for example, log and exponential, and you will choose U as log because this like the left side order. So if you see L first then E, then you're gonna choose U as L as log. So what we can do is, let's identify which one is which first. So 3x minus 1 and ex over 2. 3x minus 1 is algebraic, so it's A, and ex over 2 is E exponential. So since A comes first before then E, we're going to choose U equals 3x minus 1. And then let's put dB as E x over 2 dx. So then B would be just same as 2E x over 2. And then du would be same as 3 dx. And then if you remember, the U substitution formula is UB minus B du. So U is 3x minus 1, and B is 2E x over 2 minus 2E x over 2 and 3 dx. Sweet. So this is 3x minus 1, 2E x over 2 minus 6E x over 2 dx. And this is just same as 3x minus 1, 2E x over 2 minus 6 times 2E x over 2. So this is just 3 x minus 1 times 2E x over 2 minus 12E x over 2, and it's integrating from 0 to 2, so just plug in 0 to 2. So now this is just becomes 6, 5, 10, 10e to the 1 power minus 12e e to the 1 power, and then minus 0, plug it in 0 in 3x, minus 1, minus 2, e 0, and then minus 12, e 0. So this just becomes negative 2e, and this just becomes negative 14e. No, actually, that is negative 14e. E to the 0 is 1, so it's just negative 14. So negative 2e minus 14, so this just becomes negative 2e plus 14, which is same as 14 minus 2e, and the answer is e. So this question has to evaluate the integral, and you see x plus 2 over x plus 1 times x plus 3. Well, what you can do is use the decomposition technique. So you can write x plus 2 over x plus 1, x plus 3 as a over x plus 1 plus b over x plus 3. So you can decompose the equation, or slash, the like fraction, and it's easier to integrate this way. So what you do next is just multiply x plus 1 and x plus 3 on both sides. So this just becomes x plus 2 equals a x plus 3 plus b x plus 1. And what you do is plug in the numbers in x and find a and b value. Let's plug it in x equals negative 3. So this just becomes negative 1 equals negative 2b. So just b equals 1 over 2. And if you plug it in negative 1, this becomes 1 equals 2a. And this is a equals 1 over 2. I didn't write a part on the first equation and the plus b part, because if you plug it in negative 3 in x plus 3, this just makes that a 0. And the same logic with negative 1. If you plug it in negative 1 in bx plus 1, this will make just b 0, so you don't need to write it. So this just becomes b equals 1 over 2, and a equals 1 over 2 as well. Okay, so what you can write is 0 to 1, 1 over 2, x plus 1, plus 0 to 1, 1 over 2, x plus 3, dx, both dx. You can take out the 1 over 2, 0 to 1, 1 over x plus 1 dx, plus 0 to 1, plus 1 over 2, 0 to 1, 1 over x plus 3 dx. And if you remember this formula, if you remember it, 1 over x is same as ln x. So it's the same logic. If you see 1 over x plus 1, this will just becomes 1 over 2 ln x plus 1 integrated from 0 to 1, plus 1 over 2 ln x plus 3 integrated from 0 to 1. This just becomes ln 1 over 2 ln 2 minus ln 1 plus 1 over 2 ln 4 minus 1 over 2 ln 3. So ln 1 is just 0, and ln 2 and ln 4, if you multiply it, since you're adding those two values, you can multiply it together. So this just becomes 1 over 2 ln 8, and then if you do minus 1 over 2 ln 3. And if you're subtracting, it's a logarithmic rule, you can divide it. So 1 over 2 ln 8 over 3. So this just becomes the answer A. Okay, so this question has to evaluate negative 1 to 1, 1 over x to the fourth power dx. And easy way to do this question is draw the equation. Draw the 1 over x to the fourth power. So 1 over x to the fourth power, if you plug it in negative 1, it's gonna be just 1. And if it's plugged in 1, it's also gonna be 1. And in between values, it's gonna just go all the way up to infinity. So this kind of shows us that the 1 over x to the fourth power is going to infinities, and this doesn't like converge into like specific values, which is why the answer for this question is just divergent. Because if you look at the graph, it's just going all the way up instead of like going somewhere else. So this doesn't have a specific value to converge, so this is just divergent. So the answer is D. Okay, this question asks to evaluate from 0 to pi over 2 sine cube x cosine to the 4x dx. So let's write it, 0 to pi over 2 sine cube x cosine to the 4x dx. The small tip for this question is when you see the odd power, that will not be your u. U will be the other one that has an even power. So let's put u equals cosine x and du equals negative sine x dx. I'll explain what I meant. 0 to pi over 2, you're going to split sine cube x into sine squared x and sine x. So sine squared x, sine x, cosine 4x dx. So if you look at it, sine x is the alone that doesn't have the square value, and then you can write this with du. That's why we actually write the odd power as not as u. So this will just become negative du, sine x dx, negative du, and then u is u to the fourth power, and then sine squared x. What are we going to do with sine squared x? If you remember the trig identity, sine squared x plus cosine squared x is equal to 1. So sine squared x can be written as 1 minus cosine squared x. So negative 1 minus cosine squared x u to the fourth power du. And cosine squared x can be written as negative 1 minus u squared u to the fourth power du. And now we didn't find the interval, the bounds for the u, so let's find that. So u is cosine x. When you plug it in cosine 0, this just becomes 1, right? And then if you plug it in cosine pi over 2, this is just 0. So this is just 0, like 1 from 1 to 0, from 1 to 0. And if you want to change the bound of, if you want to change the lower and upper bound, what you do is put the negative sign in front of it and then change it. And since we both have negative sign, it'll be positive because we had the negative sign from negative du, and then we also had the negative sign from changing the bounds. So this just becomes positive. Positive from 0 to 1, 1 minus u squared, u to the fourth du. This is just 0 to 1, u to the fourth power minus u to the sixth power du. This just becomes u to the fifth power over 5 minus u to the seventh power over 7, integrated from 0 to 1. And this just becomes 1 over 5 minus 1 over 7. And if you put in 0, it's going to be just 0, so we don't take care of it. And this is just 2 over 35. So the answer for this question is C. Okay, this question asks, which of the following recurrence relations will generate a sequence with a3 equals -3? So let's just plug it in. I feel like this is really easy to just, plug it in the numbers and figure it out. So we are given a1 is 1, so let's find a2. a2 is then 1 minus 2a1, that's just 1 minus 2, this is -1. a3, let's do the same thing, 1 minus 2, a2, 1 minus 2, -1. So this is positive 3, so this is not the right one. B, an plus 1 is negative an, a1 is 1. a2 is then negative a1, so -1. a3 is negative a2, so this is 1. So that's also not true. Let's try C. an plus 1 is an plus 1, a1 is -5. a1 is -5, then a2 is -5 plus 1, -4. a3 is equal to -4 plus 1, so this is -3. So that is the right answer, but we're going to just do it all the options just in case, like anybody is confused or anything like that. So an plus 1 is -3 plus an. a1 is 0, so a2 value would be -3 plus a1, so this is -3. a3 value would be -3 plus a2 value, so this is -3 minus 3, -6. That's also not right. So E is an plus 1 equals 3an, a1 is -1. So a2 would be 3a1, so this would be 3 times -1, so -3. a3 would be 3a2, 3 times 3, so this is negative 9, so this is also not the right answer. So by the following, like just plug it in the numbers, you get the answer C. Okay, this question asks to evaluate limit n to infinity ln for n plus 5 over n. So for this question, if you plug in infinity in both numerator and denominator, this becomes just infinity over infinity. Yes, infinity over infinity. So what you can do is use the L'Hopital's rule to solve this question until you can like find the value instead of getting infinity or 0. So when you use the L'Hopital's rule, you find the derivative of both numerator and denominator. So let's do that. Limit n to the infinity ln for n plus 5 over n. And if you find the infinity, if you find the derivative of this using the L'Hopital's rule, this becomes 4 over 4n plus 5 over 1 over 1. So this is just 4 over 4n plus 5. Okay, so we have that. So let's plug in an actual value now. Limit n to the infinity, 4 over 4n plus 5. 4 over infinity is just 0. So the answer for this question is C. Okay, this question asks to find the work done pumping all the water to the top of the tank. Let's draw the tank first. It's cylindrical, it's given, and the radius is 2 meters, and the height is 8 meters, and it's half full. And we want to find the work. Work is what we learned before. Work is force times distance. And the force equation in this case can be found by multiplying the density P, multiplying the gravity G, and the volume. So Pg is already given as just P and G, so we can just leave it that. And in order to find the volume of the slice, but volume of the tank is just pi r squared height, right? So we know it's 2 meters, so it's 4 pi. But in this case, we are not sure like how much height is in there, so we are just gonna put as dh. So 4 pi dh, because even though it says it's half full, we don't know the exact like height, and it's like change of height, so we're gonna put it as 4 pi dh. And then the distance is, since this much is already full, as h, so we don't know the rest of the distance, and that's subtracting from 8, so this just becomes 8 minus h, so d becomes 8 minus h. So work becomes pg 4 pi 8 minus h dh from 0 to 4, because it's already half full. Like I said in here, we don't know the, like when you find the volume, you don't want to use the exact height as 8, because that's not the point of it. And also like in here, we don't, like, even though it says it's half full, we can't just assume it's 4. That's why we're just putting as dh as a change of height to measure all those like volumes that's kind of like measured in the like half full volume. So to elaborate that part a little bit, so this just becomes 0 to 4 pi pg 8 minus 8 dh, and you can take out 4 pi pg because they don't have any h variable, so this is just 0 to 4 8 minus h dh. This is 8h minus h squared over 2, 0 to 4 pi pg, so this is 4 pi pg, plug it in, 32 minus 8, so 24 times 4 pi pg, so this just becomes 96 pi pg. So this is, in work is done in joule, so this is just 96 pi pg joule. So the answer for this question is